Hello everyone. So we are going to discuss about one of the sorting algorithm, that is bubble sorting. So we will be discussing moving towards the bubble sorting algorithm. So what we are going to discuss, like how the sorting should be happen on an unsorted array. So let's see. Like for example, in a bubble sorting, we are having some sort of array elements. Okay, int arr. I'm having some, for example, elements like 1, 5, 3, 0, 4. So let's take an example as these are my some sort of elements which I'm having. Okay. So what should be my expected output? So my expected output should be, it should be like 1, 0, 1, 3, 4, and 5, right? So basically, what is the meaning of bubble sorting? Like, why we are doing this? Is that the only way to do the sorting algorithm, or any other sorting algorithm we are having or not? So let's discuss all those things in a very specific way. Okay. See, first of all, let's discuss what is bubble sorting. Let's have one basic meaning. What is the meaning of bubble sorting? Bubble sorting is the simplest sorting algorithm that works by repeatedly swapping the adjacent element. Means, like for example, we are having some sort of element like 3, 2, 6, 7, 1, 8. Then we have to compare with the second element, with the I plus 1 element, with the just next element, and if the element is greater than the previous element, then we have to swap it. Okay, so that we have to make it from smaller element to larger element. Okay, so let's first of all read the uh, definition of bubble sorting. Bubble sorting is the simplest sorting algorithm that works repeatedly, swapping the adjacent element if they are in the wrong order. That's what we have discussed right now, right? So this algorithm is not suitable for the largest sets, as average in the worst case of the time complexity is very high, obviously. So first of all, let's first of all code it on a code editor of a Java, and let's see how it works. Then we will discuss on a very specific way by doing a dry run. Okay, one by one how the code is working. Okay, so let's move toward the code editor. Okay, so let's take one integer array. So this is how we declare array, and we have to put some sort of elements here: 1, 3, 0, 4, and for example I have taken 5. Okay, done. So guys, please tell me what should be the expected output for this. It should be like 0, 1, 3, 4, 5, right? Okay, let's move forward. So let's take an length. Let me capture the length of an array in the variable n. Okay, let's do it as of now. Okay, now we will be moving forward with for loop. Okay, for example, like right now we will be doing a taking one for loop. Integer I is equal to 0, I less than n, I plus plus. Okay, so I want to take one. I have taken one for loop, and again I have taken one another for loop. Int j is equal to I plus 1. I'm just comparing the element with the second element. If it is greater than the next element, we will have to swap. Otherwise, we will be moving forward, right? Okay. J less than n, j plus plus. Okay. So now we will have to compare by using a if statement. We will have to compare the zeroth element and on the zeroth index value and the first index value first of all. So we can do it like if ARR of I is greater than ARR of j. Okay, one second. Okay, then if this condition satisfy, then it will come inside this if statement. If this condition is true, then we will have to swap this. So let's create one temp variable, and inside the temp variable we will be storing one we will be putting the value of ARR of I, and we have basically what we have to write the code of swapping of the two array. Okay, so equal to temp. Okay, so this is the logic that we have written till now. Okay, so after that, let's create one again for loop. Okay, sys out of ARR of I. Okay, so up till now we have done with the code, and let's run the code and just check it out like what's happening. Okay, let's make it much more concise. Hold on. Yes, so 0 1 3 4 5, that is what we got the expected output. Now for you people, like you must be like asking me, sir, what is this, why these things are happening, how these things, how codes are working internally. I want to know each and every part on a very specific manner. Okay, so okay, let's deep dive on a dry run part. Okay, so that we will be understanding how code is working internally, how the swiping done, and all everything. Okay, so let's deep dive into the dry run part. Okay, so one second. Let's remove this and okay. So let's take an array. Okay, let's make it into two halves. Okay. So I have one array ARR. So in this we are having, sir, 1 3 4 0 5. These are some sort of elements we are having, right? So can we make it on our internally what array look like? We can draw like this, right? 1 3 4 0 and 5. So for an array we are having index also. So we are writing in index, zeroth index, first index, second index, third index, and fourth index, so and so on. Okay. So what is my code? So let's talk about my code. Like I have written initially, like for loop, I have created one for loop. Inside the for loop, I have written int I equal to 0, semicolon, I less than n, I plus plus. So basically in this specific part, we have again taken another for internal for loop. This is called internal for loop. Inside one for loop, we are having another for loop. So in this we have taken int j is equal to I plus 1. Okay, j less than n, j should be less than n, and j plus plus, right? So these are called the internal for loop. This loop is called internal for loop. And now what we will be doing here, so let's take at the backstage, like we are having I initially equal to 0. Okay, and j should be like I plus 1. That means I is initially 0. That means j becomes right now 1. Yes or no? Okay. So let's make much more clear. Hold on. Let me remove this part. Not mandatory as of now. 13405. Okay. Remove this part also. Okay. Done. So this is my array. 1, 3, 4, 0, 5. Of index 0, 1, 2, 3, 4. Currently my I is here and my j should be here, right? Because I is 0 and j is 1, right? Any doubt in this? No. Okay. Now again I'm having one condition in the internal for loop, like sir, if ARR of I is greater than ARR of j, then we have to internally swap. If this condition satisfied, then okay. What if statement says now कि inside the condition, inside the if statement, in the if statement, inside the condition it returns the boolean value, right? It should be either true or false. We can say like that. It should be either true or false. Okay. If the condition satisfy, we will be moving forward with the true. Else, we will be moving forward with the false condition. Any doubt till now? Probably not. Okay. So now we will be moving forward with the I is equal to 0 and j is 1. Now let's take ARR of 0. Okay. Now what should be in? We will be moving forward with the if condition. If ARR of 0, okay, is greater than ARR of 1. What should be the ARR of 0? That is 1. 1 is greater than 3. Condition satisfied or not? Not satisfied. So it will move inside the false condition. It will not go inside this if condition. Again, the iteration move forward. Okay. So now I will be 0 here only. J becomes now 2. Okay. J becomes now 2. So J becomes now 2. So now J should be pointing towards this pointer. Let me take on a black. J should be pointing here now. So now comparing from the first element again with the I. So if ARR of 0, ARR of 0 is greater than ARR of index 2, condition satisfied or not? 1 should be greater than 4. Yes or no? No. Again we will be getting false condition here. Understanding? So moving forward, we got increment of j now become 3 here. Okay. ARR of 0 greater than ARR of 3. 0 is 1 greater than 0. Condition satisfied. We will go inside this condition. Okay. It will go inside this condition and it will do the swapping accordingly. This 0 will go here and 1 will go come here. Any doubt till now? No. So in this condition, like right now the swapping happens. Similarly, in another case also, like ARR of 0, we will be if greater than ARR of 4. So 0 greater than 5. Condition satisfied or not? No. It will be again false. Okay, the things got messed up a little bit. So let's remove some sort of lines. Okay. So now one first iteration is done now. Okay, let's make it on green. Okay, the first iteration is done. So now I initially I is 0 and j is like on the condition of like 4, right? Now the first condition gone. Now I becomes 1 and j becomes I plus 1. Now j becomes I plus 1. So now I should be 1 and j should be like 2. Any doubt in this? No. Okay. So moving forward, like now we are having a condition now. We are having I in this point and j should be pointing here now. Okay. So again we have to iterate and we have to compare with the next element. Okay. So ARR of in the if condition we will be checking out. Okay. If ARR of I that is now 1 is greater than ARR of second element, 3 is greater than 4, condition not satisfied, it will return as false, so it will not go inside the if statement. Okay, again iteration move forward. Okay, I j become will j become 3. Okay, then it will compare with the next element. So on the next element it should be like ARR of 1, that should be greater than ARR of third. So yes, this in this condition it is got satisfied. So 3 is greater than 1. Yes. So now this will become here and this will go here. Okay. So it will be like 1 will come here and 3 will go here. This is what we are doing, the how code is internally working, and we are getting the values according to the values what we are giving. Okay. So this is how the logics work. Okay, let's remove this and okay. So now again we have to compare the similar iteration and we have to do the according value condition. Okay, so at the end similarly we will be getting the value as 0, 1, 3, 4 and 5. That will be my expected output. So let's visualize it. Okay, so because that is what we have learned internally how the code works. Okay, so now let's visualize it by watching an animation. Okay. Okay. So now you can visualize it like how we are having some sort of elements like 3, 2, 6, 1, 7, 8 and all. So in this condition you can check it out like if the element is greater than the previous element then it is leading to swap. The smaller element is coming forward and the bigger element is getting backward. Okay, internally how it is working, similarly like it's comparing with an adjacent element and just swapping it if the condition satisfied. Okay, like that is what it is written on the definition as well, that it works by repeatedly swapping at the adjacent element if they are in the wrong order. Okay, so why we have discussed that in this definition this algorithm is not suitable for the large data sets because the time complexity of this code is O of n square, which leads a very much of time taking process. So for removing this process and making it much more complex, we are having different sorting algorithms like quick sort, selection sort, insertion sort, merge sort, heap sort. So these sorting algorithms are much more efficient than this bubble sorting. Okay, so we will discuss it on a different class or the next class. regarding that. So that's all for the bubble sorting. Thank you so much.